The Final Frontier is one of the most famous opening lines from my favorite sci-fi show, Star Trek, or the Star Trek The Next Generation. It's famous for showing space cultures. It's one of the first show with multiracial cast and showing different type of culture. So I love, and the most important is space exploration. It show a lot of facets of space that we probably doesn't know, and we don't know if this is true or false because we haven't really explored space that much as a society. Ever since I was a child, imagine that it's child is me, but it's brown and you know not fat, I guess. I always fascinated by the sky, the space. I always want to just do something with it for ever since I was a child. I remember reading Quark, one of the cheapest like science magazines when I was a child, and I just loved the astronomy section. I even studied astronomy in high school. I go to Olympiad with it. That's why I just mechanical engineer because I want to be someone who works on that facets, to works on space, to be at least become a master's at aerospace engineering. That's why I want to be one. That's why my optimization project is called Gun Control System Optimization by using rocket trajectory simulation with a medium-sized electric data fan as a case study. It's a little more jumbo, but the main point is this. Uh, what is a gun control system? A gun control system is basically a system or people or person that controls the rocket. It doesn't have the rocket, it could be plane or other thing that controls the data and the navigation of the plane from the ground. They monitor also the data of the plane. Is it flying correctly? Is it reaching the correct speeds and stuff? Now, this is not me, of course. It's just a weird Russian guy just called Ivan. Ivan will monitor what is happening to the rocket. Is it reaching correct speed and correct height? Is there a problem with the acceleration? Basically, but mostly mapping. And I want to remind you that because of that, he doesn't control much. We need to remind you that when the rocket is launched, you cannot do anything to it. You must let it launch, fly, and finally fall. And because of that, the ground control system only control navigation, and the mission control usually on at the first start of the flight or the launch. After the launch, they control no more. They only can monitor it. And for me, of course, that is without any proper data. We don't know what is the probably gonna problem of the on the plane when it once launched. What if when it reached I don't know, like a certain kind of height, the wings start to vibrate and create problem. We don't know that. That's why we need a simulation. We need to simulate the trajectory so that we know which what is the problem and where it's gonna be fly on. We can simulate it using we can simulate with numerical method. Why do we need to simulate it? From the data of the simulation, we can know which the maximum distance of the flight, and we can simulate it and know what which part is going to be problem, and we can map it and we can know where it's going to land and where it's going to fly to. Now, of course, how do we to do it before I explain it, we need to ground the application project. And to ground it, I choose to use one of my project for my robotical group in TRUI, MAT, this the rocket research organization. I choose my EDF rocket. Again, this is a medium sized one, so it's not that big. Because it is an EDF rocket or electric direct fan, it's electrical. This rocket is not that big. And for the mission, I used again one of my competition competition mission. The rocket must be launched at an elevation angle of between 50 to 70 degrees, and after it's 175 meters, the engine will shut off, and it will when it reaches 20 meter, parachute will be launched, and it will try to land. Now from here, we before without simulation, the ground control system only can rely on GPS where to shut off the engine and turn on the parachute. But with the simulation, we can create an estimate of time to know when it launched, and we can also map better than without just using a GPS. Because again, just basing it on height and height only, we cannot determine the perfect time to launch it and the most efficient and better time to reach the perfect distance. Again, the competition problem is that we need to reach the farthest distance. So it is better to have better guided data to control it. Alright, so how we do it? First, we will do CFD analysis. We need to find the drag and the lift from each rocket at different angle at different time, and by that we can just by thinking the thrusters of the rocket. Then after that we can map it or graph it the distance of rocket each, and we can finally find out what is the maximum distance and what is when is the perfect time for it to be to shut off, and when do we need to put those the parachute. Therefore, we can improve on the ground system by making their life easier, and we can we can determine when is the perfect time for doing something, and we can also have the mechanics if we need to find, oh, at this height the rocket fuselage start to vibrate and stuff, so we can know it better. To find out more, you can read on my CCIT post. Thank you for your attention.